Hello viewers, welcome back to my channel Experience Physics, and in this class we will be discussing the most important topic as far as physics subject is concerned, kinematic equations, right? Let us see what are kinematic equations and their proof. The proof can be done in two ways. One is graphical method and the another is integration method by calculus. The proof of kinematic equation can be done in both ways, but we will be taking this method, integration method. In this method, we are going to see the proof of kinematic equation. So before going to see the proof, let us see what are kinematic equations. Kinematic equations are otherwise called as equations of motion. Equations of motion. An object is moving from one position to another position, and the equation governed by this motion are given or described by the set of equation, kinematic equations. So before seeing the proof of kinematic equation, let us see some basic definition of some terms. Distance, fundamental quantities, also displacement, then speed, also velocity, then acceleration. These are fundamental quantities and fundamental terms, right? Distance or displacement. So this is a scalar, distance is a scalar, displacement is a vector. An object is moving from one position to another position. In this way it is moving. The total distance covered by this object from one position to another position, say this is position A and this is position B. Between position A and position B, the object is moving. The length traveled by the object is known as distance. The length, the total length. And this is the shortest length. This yellow line is the shortest length. This is displacement. Sometimes the object can move along a straight line from A to B. In this case, distance and displacement are same, right? So a detailed video has been made to explain about distance and displacement, speed, velocity, not acceleration, distance, displacement, speed and velocity for these quantities or for these terms. A separate video has been made and its link is given in the description box. If you are interested, you can go and watch that video also, right? So these are some basic definition. Distance or displacement, we will use the letter to denote it. Letter S. Speed or velocity, V, and this is A. The unit is, this is unit of S is SI unit. Unit of S is meter, and velocity meter per second, and acceleration meter per second square. Yes. So these are the SI units of these quantities, distance or displacement. So if distance is taken, it is scalar quantity. If displacement is taken, it is vector quantity. Vector quantity means it involves the direction, but distance doesn't involve the direction, right? Irrespective of the distance, direction, the length traveled by this object is known as distance. So no direction is given for displacement from A to B or B to A, right? So it's a vector quantity. Similarly, speed is a scalar quantity, velocity is a vector quantity, acceleration also a vector quantity, right? In a separate video, you can know these terms, right? So these are the SI terms, SI units, meter, meter per second and meter per second square. From this, the basic definition for speed. For speed, we will write V is equal to ds by dt. change in distance or change in displacement, right? How it is changing, how fast it is moving. The object is moving from one position to another position, whether it is moving slowly or it is moving fast. How fast, what is the time it is taking to displace, right? So this is change in distance divided by change in time, or change in displacement or change in time, right? So this is known as velocity, right? And A, dv by dt. How the velocity is changing, right? You can see in an aircraft or aeroplane, right? It is taking off. It is taking off from the airport. Then it is cruising, right? At a constant speed, it is cruising. Then it is landing, right? So three phases. It is taking off at a constant speed. It is taking a constant acceleration. The velocity is changing. Gradually it is changing. Then the velocity is kept constant from Delhi to London, or Delhi to UK, Delhi to Dubai, right? It is cruising. Cruising means at a constant speed. Then it is landing, right? Once it is reaching the London area, it is landing, right? So when it is taking off, the acceleration is constant, but it is velocity is changing at a constant rate, dv by dt. Velocity is changing, right? Here velocity is not changing. Once it reaches its altitude or the height, it is constantly moving. The velocity is moving. It is cruising. So no change in velocity in this phase. So acceleration is said to be 0. Then it is landing off. Slowly, deceleration. It is known as deceleration, negative acceleration. The brakes are applied to stop the plane, right? So A is equal to dv by dt. Change in velocity by change in time. These are from definition I am writing. From definition. S is the distance or displacement, the length of the path it traveled, or length of the displacement, right? Length of the line, length of the straight line, right? We change in the distance or displacement, a change in the velocity, right? So these three equations are used to derive the equations for kinematic equation or equations of motion, right? Number one, V is equal to U plus AT. Kinematic equation number one, V is equal to U plus AT. Number two, S is equal to UT plus of AT square. Number two. Number three, V square minus U square is equal to 2AS. So these are the three equations which are known as equations of motion or kinematic equation. So in this video lecture, we are going to see the derivation of these three equations by integral method, right? By the way of calculus, we are going to derive the equation, right? The first one is V is equal to U plus AT. The second one is S is equal to UT plus of AT square. The third one is V square minus U square is equal to 2AS. First we will know the terms. V we know what is U. A we know, T we know, S we know, right? Let me write what are them, right? This is the starting place, position A is A, this is position B. Two positions. From here to this position, the object is moving. This is distance or displacement. S is equal to 0. Here S is equal to S, right? So total distance or displacement. If the object is moving along a straight line, right, you can say distance is also equal to displacement. So S is equal to 0 to S is equal to S. So time, initial time, T is equal to 0 when it is starting. final time t is equal to t. Right. Initial velocity, that is u. Initial velocity, final velocity, this is v. Then the acceleration a. If the velocity is changing, the term a will also come. So the initial values s is equal to 0 to s is equal to s, t is equal to 0 to t is equal to t. Velocity u to v, not 0 to v. U to v, initial velocity is u. If it starts from rest, it may be 0. Right? After it started, some time is we are considering. So that is why we are using the term u. Initially, it has some velocity. After it started, we are considering the calculation. So initial velocity is u is equal to 0, not from the rest, right? U v. From the definition, a is equal to dv by dt. Acceleration is equal to change in velocity over change in time. From here, I am going to start the first derivation. Acceleration is equal to dv by dt. So this is one variable v. This is also variable t. dv dt. So both are changing, right? We will separate them. Separate the variable. dv by cross multiplying it. dv is equal to a into dt. Right? Integrate both side. Integration of dv is equal to integration of a into dt. Right. The limits are for v, we have to substitute the limits. Initially it is u, finally it's v. So this is u, this is v. Here with respect to time we are integrating. So t is equal to 0, t is equal to t. So this is v. Integral of dv is v. The limits are lower limit u, upper limit v. So this is a. Please remember, students, please remember, these kinematic equations are used when a is constant, acceleration is constant, right? Acceleration is constant. This is important point. Or uniform acceleration. These three equations are used. They are useful only when acceleration is constant. It is also known as uniform acceleration. The acceleration is varying. We have to come to use this equation, not those equations, right? So if acceleration is constant only, we have to use the kinematic equations, right? If they are varying, we have to come here, the fundamental equation only, right? So a is constant, so I am taking it the outside. So integral of dt will be t, 0 to t. Since this is constant and dt, integral of dt is t, lower limit is 0, upper limit is t, right? This is v minus u is equal to v upper limit minus lower limit is equal to t minus 0, or v minus u is equal to at, or v is equal to u plus at over. This is number 1, equations of motion, kinematic equation. Equation number 1, v is equal to u plus at, this one. Final velocity is equal to initial velocity plus acceleration times time, right? Then we will derive the second equation, this one. Distance or displacement is equal to ut plus half at square. This one we will derive, right? To derive it, we will take this one. V is equal to ds by dt. From this definition, we are going to derive it. V is equal to ds by dt. V is equal to ds by dt. Change in displacement over change in time. Again, we will separate the variables. ds is equal to v into dt. V Just now we have derived it. V is equal to u plus at. That is equation number 1. V is equal to u plus at. I want to substitute here. V is equal to u plus at. Then dt. This side it is ds. So we will integrate both sides. U plus at dt. It is with respect to s. S initial value is 0, final value is s. Here with respect to t, initial value is t 0, final value is t. Right. So this side s is the term which is coming, its limits are 0 to s, and this is u plus at into t. So u first, if you integrate it, the ut is the result. Time limit 0 to t plus a is constant acceleration. Then for t dt, it is t square by 2. Integration, basic integration you have to remember, right? So t square by 2, 0 to t. For basic differentiation and integration also we have made a separate video. If you are interested, you can watch it, that video also, right? How at, integral of at dt, how it is coming as a into t square by t, right? That video, if you watch it, you can learn them, right? So this is s minus 0. This is u, t minus 0, ut minus 0, right? Plus a by 2 t square minus 0. So this could be written as s is equal to ut plus of at square. This is equation number 2. S is equal to ut plus of at square. S is equal to ut plus of at square, right? So students, if you notice these 3 equations, here s is missing, no s. In the first equation, there is no s. In the second equation, there is no v. In the third equation, there is no t. So there are actually 5 terms. Here there is no s. Here there is no v. Here there is no t. So in the third equation, for the derivation of this third equation, we have to eliminate time, right? First we have to eliminate the time, and we will easily get the result of v square minus u square is equal to 2as. For it, I will take this equation, a is equal to dv by dt. From this equation, I will come to derive the third one. A is equal to dv by dt. As I said, we have to eliminate t. The dt should not come here, right? For it, I am going to multiply it with ds by ds. The value won't change, right? Then we will replace it. Just interchange it. The dt, the denominator part is interchanged. dv by ds multiplied by ds by dt. dv by ds multiplied by ds by dt. ds by dt, change in displacement over change in time, we know this is v. This is dv ds, right? So a is equal to v, let me write here, v times dv by ds. So this is one important equation. Intermediately we are getting acceleration can be written as v times dv by ds. So there is no time factor here. So how the velocity is changing, how the distance is changing, how the time is changing, it is not coming here. A is equal to v dv by ds, right? As usual, we will separate the variables dv ds, right? A into ds is equal to, or v into dv is equal to a into ds. V, integration of v dv is equal to, a is always constant, so let me take here, then integral of ds. So this is v dv with respect to v. So the lower limit is 0, the lower limit is u, upper limit is V. Here S is equal to 0, S is equal to S, upper one. U lower limit, V upper limit, V dV is equal to A of integration 0 to S and ds. So this equation I have repeated here also. V dV, this is V square by 2 U V is equal to A of S 0 S. So this is V square by 2 minus U square by 2 is equal to A of S minus 0. So V square minus U square by 2 is equal to A into S. The 2 can be taken to right hand side to get the final equation. V square minus U square is equal to 2AS. Yes. V square minus U square is equal to 2AS, the third one, right? So there is no time factor here, right? So these are the derivation of the important equations of motion or kinematic equation, which are very, very useful for us to describe the motion of a particle from one position to another position, right? If S is not in the data or not in the question, we will use this equation. If V is not in the data, right, when you go and solve the problems, if V is not in the data, if V is not given, and also V is not asked, we can use the second one. Similarly, time. Time is not given and the time is also not asked. Right, in the question, if time is not asked, we will use the third equation. So these are the derivation part of the kinematic equation, right? For this part, distance or displacement, speed or velocity, we have made a separate video as far as many as 24 worked examples also solved. I have solved in that video 24 examples involving this topic, right? So please students, if you are interested, you can watch that video and you can learn how these 24 problems have been solved, right? To prepare for your NEET examination. Thank you for watching and all the best.